a lost world lurks beneath us. Something is hiding deep under our feet. It's a ghost. A ghost of a world that came before our own. Scientists now believe they have found the first tantalizing clues of a proto-Earth. This isn't just old rock. This is material that could be 4.5 billion years old. It might be a leftover piece from the very moment our planet was born. Imagine a fossil, not of a dinosaur, but of the infant Earth itself. This ancient remnant is not just anywhere. It's located in one of the most inaccessible places imaginable. It sits near the boundary between our planet's molten outer core and the thick, rocky mantle. The discovery is like finding a single, untouched brick from the original construction of a skyscraper that has been rebuilt 100 times. This material could have survived billions of years of planetary chaos. Earth has been a violent place. Continents have crashed. Oceans have formed and vanished. The planet's interior has churned like a boiling pot of soup. Yet, this small pocket of history may have remained undisturbed. The location of this find is staggering. It's situated more than 2,800 kilometers straight down, a realm of crushing pressure and unimaginable heat. It's a place we will never visit. This isn't a sci-fi story. It's the result of painstaking work by a dedicated team of Earth scientists. They weren't digging with a shovel, they were listening. They were listening to the echoes of our own planet. Using waves from earthquakes, they have created a picture of this hidden world. What they saw in their data was an anomaly, something that didn't fit. A region of the deep mantle was behaving strangely. Its properties didn't match the surrounding rock. The only explanation that seemed to fit was that this material was profoundly, fundamentally different. It was old. The idea shocks our understanding of how planets work. We used to think the early Earth was a giant melting pot. Everything got mixed together in a fiery cosmic stew. All the original ingredients were blended, recycled, and transformed. This discovery suggests that's not the whole story. It implies that some of the original building blocks were never fully mixed in. They were preserved like a drop of oil in a vast ocean of water. These primordial reservoirs hold the chemical secrets of our planet's formation, waiting for us to find them. This is a message from the dawn of time. So, how do you find something that's thousands of kilometers beneath the ground? You can't drill a hole that deep. The pressure and heat would destroy any machine we could build. Instead, scientists use the Earth itself as a giant medical scanner. The X-rays in this case are seismic waves. These are powerful waves of energy released by earthquakes. They travel through the planet from one side to the other, and as they travel, they carry information. They tell a story about the materials they pass through. This is the science of seismology. Think of it like this. When you tap on a wall, the sound tells you if it's solid brick or hollow drywall. The sound changes based on what it travels through. This discovery is more than just a geological curiosity. It has profound implications for how we understand our planet, from its deepest core to the air we breathe. First and foremost, it gives us a direct window into planetary formation. The first 500 million years of Earth's history are known as the Hadean. It was a hellish, chaotic time. The geological record from this era is almost completely gone. If these deep reservoirs are what scientists think they are, they represent the first physical evidence from that lost eon. We can stop guessing and start measuring. The deep mantle is not static. It's in constant slow motion, a process called convection. Hot plumes of rock rise from the deep interior toward the surface. These plumes are responsible for hotspot volcanoes like those in Hawaii and Iceland. The presence of these dense, chemically distinct blobs of proto-Earth material could influence this flow. They could be anchoring the plumes or altering their chemical composition, shaping the geology we see on the surface today. The planet's magnetic field, which protects us from harmful solar radiation, is generated by the motion of liquid iron in the outer core. The heat that drives this motion escapes through the mantle. If there are ancient dense structures sitting on top of the core, they would act like insulation on a pipe, changing how heat flows out. This could affect the history and stability of our magnetic shield, which is essential for life on Earth. Everything is connected. We've walked on the moon and sent rovers to Mars, but the world beneath our feet remains a great mystery. We are like people living on the thin peel of an apple, with little knowledge of the fruit inside. The journey to understand this proto-Earth material has only just begun. The evidence from seismic waves is compelling, but it is indirect. We cannot simply go down and get a sample. Therefore, the next steps for scientists will be to gather more data and refine their models. They need to confirm that what they are seeing is truly a ghost of the ancient Earth and not some other, less exciting geological feature. By combining seismology with mineral physics, the study of how materials behave under extreme pressure and temperature, they can create more accurate models of the deep Earth.